Bonus points for getting an IDE going. I do recommend everybody download VS Code. It works on all the operating systems, and it's basically there's a jump when you go from running like print hello world and just like a few lines to actually wanting to build in a file that's anything more than like 5 lines. Just skip to writing in files instead of writing on command line. Your life will be so much easier. And from that point forward, you're going to be using Python files anyway. So just the old process I used to have with the IDE was, first of all, set it to autosave. Actually, let me spend just a minute on it. So Video Studio Code, it supports any language, generally speaking. And the main thing that these IDEs do is that they color code the syntax. So there's reserved words, like return is a reserved word, and so it colors it that, and then like variables and floats and stuff are the other colors. That's the main thing. One thing I recommend right away doing is File, go to this and click Autosave. Make sure that's checked. What that does is, as I'm typing, it automatically saves it. And let me just turn that off for a second. If you don't do that, then the default is you'll see this little red dot, or sorry, this white dot. That means your file's unsaved, and you have to do like a Control S. It's kind of a bother because you forget to do that. But the idea here is that you also want to go and do View Terminal. If you haven't opened it before, I think like the first time you have to manually open it, View Terminal. This is your command line. Every operating system has a command line. We covered that a little bit before. And from there, you should have your good old Python. This is part of the install process. Make sure that Python can run from your command line. Ask me for help if you're having issues with that. And at that point, you just pass it the name of my file. So you'll have your files over here. I think it defaults to the left. I prefer the right. But you can do, you'll create main.py or whatever. Print, we'll do something a little bit different. So def first function. I'm going to do pass. That's just a placeholder. If underscore underscore name underscore underscore equal main colon, then do something. And the thing I'm going to do is first function. All right. So if I were to run this, it wouldn't work because you see this dot right here. I haven't saved it. So I'm going to Control S. And before I go insane, just return on autosave. Now in terminal, call the script. So that's Python and then the name of the script. You obviously have to be in the current folder. I'm going to ls actually to see what's here. Oh yes, there's my main.py. It's in the same folder as this. Change directory if you need to change directory. But we're going to do Python main.py. And well, it doesn't do anything, but it does run. We'll go ahead and change this over to a print hello inside function. Print let me make sure. Am I in the command prompt? I should be. Python main.py. Okay, definitely taking crazy pills. What's going on? Oh, it's probably because my if statement is wrong. Hold on. It's been a long time. In Python, what is the standard way to test if current file is main underscore underscore main? Sorry. Teaching bad conventions. All right. So a little bit of historical background. These underscores are generally considered internal Python variables. And what's happening here is that when you launch Python, it does set up an environment for you, and there's some like hidden variables. One of them is the name of the main of the file that you're in, and the one that you launch, this very first Python that you launch, has this name underscore equal to main. That's just a default. And so what you're doing is you're saying, if I am the main file, then run me. And this is useful in situations where you might have multiple files. So there's this main here. I'm gonna create a new one called second.py. And then in it, I'm gonna have, also, I'm gonna just copy this, change this over a little bit. So second function, hello, function 2. And then if main, we're going to call second function. All right, so now if I run, obviously this is identical conceptually to the other one. If I run second function, it says hello function 2. Now let's do something a little bit different. Let's go back to our first file, and we're going to import the code from that other file. So we're going to do from second import star. So just import everything. So that should give us access to the second function. So after first function, second function, call that. Now if we run the main, we say if name equal main, first function is called, and then second function is called. What's very interesting here is that you'll notice that this block of code is never actually run. Let me make this a little bit more clear. If it was run, print, this is second called as main. I'll run it again, prove, nope, not there. But when I run it directly, it is run. And so what's happening is this is a little indication on which of the files is the first one to run. And so a lot of times when you run your first file, you're running your main.py, it executes it from top to bottom. So let's follow the logic really quick. So the line 1, from second import star. Now the first thing it does when it gets to this line is it loads this file. And so line 1 creates a function called second function. It doesn't call it, but it initializes it. Okay, it continues to line 4. If name equals main, well, it calls this if statement, but it's going to return false. So the name is not main. It is not the main file. This is not print. It gets to the end of file, then it returns. Now it's returned, and we have loaded all of the functions that were in the other file into this right here. Another way of doing this import, you might just see import second. So now I'm not saying with the wildcard star, I'm just saying import second. You'll notice that the IDE makes this squiggly, and it says, which is a hint that there's a syntax error, and you see second function is not defined. So in this syntax, what you need to do is call the name of the library and say dot. So we're calling second dot second function, and it still works, but it's just When we did the other method, we were directly importing the function names into main. And so first of all, you want to make sure there aren't any function name collisions. They should be called different things. But if you're worried about stuff like function name collisions, just import it as this, and then you can just do second, you can just call it directly. And then lastly, sometimes you see this where you give it another name, just a shorter name. You can say import second as sec or something, and then this would just become sec. And you're just giving it a cute little human name. That's the main project that does that is NumPy. You'll see import NumPy as NP. That's very common. NumPy is a library that gives you multi-dimensional arrays. So just think of the lists that we had before, right? So basically, my list equals, you know, apples and oranges. Well, think of a list of lists now. My list of list equals, and then I could say that the element 1 is my list, and element 2 is just this other list. So dogs, comma, cats, etc. So now I have a list of lists, and if you think about it, if you were to index to the 0th element of my list of lists, so my list is my list of lists at the 0th element. That's returning a list type object. And equivalently, you could say my animal list equals the first index. And if you see, all of this stuff is actually a single index. It's wrapped in these square brackets. And so you're just saying, here's a list type object. It goes into the second position. And in fact, any object could be a list. There's more complicated things that we'll get to very soon. So that's a bit about importing. The magic of Python really comes down to the fact that there's a library for absolutely everything. Python is one of the largest, most supported programming languages. It has a tool for everything. That's kind of what it's known for. And so it's very easy to get going with projects and algorithms because there's probably a reference that you can just import and start using right away. So we kind of breezed past it, but hopefully there's some context here. This is a function. It does a set of code. Let's see, my int equals 2, and it can return something. So we'll return my int times my int, we'll say. And so now when you return it, you can capture it on the other side. So the idea is that a function is a repeated chunk of code. It's something you can use again and again. So let's see, for example, here I'm going to set squared output equals whatever first function returns, and then you could say second squared output is just the same thing again, and then why don't we just go ahead and print first output was colon space plus the string of squared output. We know it's going to be a float because a float times a float is another float. This is saying return 2 times 2. Technically, it's doing that twice, so we expect to see the same thing twice. Second is colon plus the string of second squared output. Let's just go ahead and run that. So first of all, it prints hello inside function twice because it calls the function twice. It calls it once on this line 16 and once on this line 17. So every time it's called, it goes to this set of code and does that code. And so again, the key concept here is that a function is a repeatable set of code. And if you just hard code everything, it's a little bit useful, but it's much more interesting if you start to introduce what are called parameters. And parameters are things that you pass into the function. So let's call my starting int and then let's set my int equal to my starting int. So now we're taking whatever we're passing in and we're squaring it. So now we need to pass things in here. So let's start with a 2 and a 3. So first output was 4, second is 9, right? So we are able to reuse the code that involves squaring, and all we have to do to square any number, any object in the future is just to pass it in. Recall that Python's pretty flexible with types. You as a programmer need to be on top of it. So in this case, I passed in 2 ints, and so this is int times int. But it would theoretically work with a float. We could do 4.0, because I don't know what 2.4 is squared, but I know the other one is 16. So 5.76 and 16 is these two squared. So this is really handy because now instead of sequentially, writing, squared output is this times this, squared output is this times this, and like especially when it gets longer and longer, you just define a function one time and you can pass things into it. You can also pass multiple things into it. I'm going to say subtraction value. And so let's do, I'm going to return now the math of this squared minus subtraction value. So whatever that is squared, say minus 1. Whatever this is squared, say minus 2. So 5.7 minus 1 is 4. 16 minus 2 is 14. And so now I have a very kind of fancy function, and without having to rewrite much code. I'm starting to use variables and just passing in variables and only applying the actual parameters when I'm actually calling the function. So that's really cool. So let's proceed now to the second to last thing I'm going to teach with basic Python, which is creating a class. So this is going to be a crash course on object-oriented programming, but a class is a collection of repeatable, it's a data structure that holds data that follows a certain template. And so, for example, we're going to create a class called student. And so I believe it's initialized like that. By convention, classes start with capital letters. The first thing that you're going to define is an initialization function. And we're also going to set up some attributes. So every student has, let's say, a first name. It's going to be an empty string. Last name is an empty string. Let's give them an age, which is going to be a number. We'll just default to 0. And I'm going to do just a family member names as a list. So you can pass a list of family member names. So these are setting up what are called also, I think they're called class attributes. And this is a very special function. It's an initialization function. This runs only one time. It runs the one time when you're first setting up this data type, which we'll use in just a second. And what you do is you pass it in your starting attributes. I'm just going to load it with some parameters. Fname, lname, current age, family list. And so these are things that we're going to pass into it when we're setting it up. And what we're going to do is we're going to use this very special notation, self dot, and then you can overwrite instances of these properties. So we're going to say self.firstName equals fname. This will make a little bit more sense when we make some progress. So I'm just going to f.lastName equals lname. Self.age equals current age. Self.family member names equals family member names. So all we're doing is we're passing in 4 parameters, and then we're setting this object's internal variables to those things that we set up. Later, we can do interesting stuff with it. So we're going to give this class a function. When you have a function inside a class, it's actually called a method. So a method is anything that we're going to use these properties for. So let's say get full name. And you don't need to pass anything in this case, but we're going to say return. We're going to return self. I do have to pass it self, actually. It's a reference to the object itself. That's a convention. Return self dot first name plus space plus self dot last name. Okay. So we've set up a class. Let's go ahead and use this class. So first of all, let me start over with these imports. I like to do the import second. It's like the most general way to do it. And then let's put down here, we'll just add some more. So first student equals second dot student, and then we pass it the attributes in order, right? So Matt, comma Zamora, comma 37, comma, and then a list object. And it doesn't really matter which list. It was intended to be a family list. We'll say Paul, comma Lauren. And then let's create a second one, second student. And then we call that same class the student class. And let's pass it Olivia Zhao, comma, gonna guess you're, I don't know, 55. I don't know how old you guys are. And then family, we're gonna say dog and cat. Okay, so what you should notice based on the syntax is that I am repeating a template, and the template is that for every student object, I can pass it the parameters, and then I can call these things and do stuff with them. So I could print the students enrolling today are colon space, and let's just do a new line print. Let's do first student dot get full name, print second student dot get full name. Let's go ahead and run that. So the students enrolling today are Matt Zamora, Olivia Zhao. So going back to the class, this is what's called object-oriented design. You're designing an object that is a complex data structure. It's basically an object generally made of Python primitive data types like strings, integers, lists, just kind of more primitive data types. But you're using that to create kind of a recipe that you're repeating every time you initialize an instance of that object. And then instead of, reinventing a lot of the things that you generally need for students, you are just creating these methods for the class, and then you're just able to call those based on the whatever your class attributes are. So I know that's a lot of language and buzzwords. So let me take a minute to let folks ask some questions. So who is unclear on kind of the idea behind object-oriented design? Let me start with Olivia. Olivia, what are some of the advantages that might come up with object-oriented design?
I guess like making the code able to like be reused.
Absolutely. It kind of, one of the other benefits is that you're kind of thinking of things how you would think of things. So let me actually code up another example that might also drive home object-oriented design. I'm going to design a class like a school class. So again, by convention, classes have capital letters. So I'm going to create a class. That's maybe a bad name. I'm trying to say school class. I'm gonna call it school class. And all it has, let's say, well, let's give it a few things. Let's give it start time. We'll make that a null. A none just is a null value. It means it's kind of empty. It's a non-existent value. So we're setting that up as placeholder. Give it a null, and then student list equals this empty list. Let's give it a few convenient functions. So def All right. Def add student. We always pass self in as the very first thing because you have to call it when you're referring to these attributes up here. Def add student, and then we want a something, we're going to call it current student, and we're going to do student self dot student list equals, so we're going to re-declare it or reset it. We're going to set it equal to itself, self dot student list, but with an append of the current student. So we're going to append the current student. And this is one of those instances where, let me just run a quick check that I'm getting this syntax correct. So my list equals this, and I want to do my list dot append let's call it test. My list is now, okay, so never mind. I don't need to set the equals. The append automatically updates it. So in this case, we'll just say dot append because it changes what it's made out of. And that's it. There's no return statement. It just does it. But let's also do a get class roster, and we're going to return pass in self. We're going to return self dot student list. Okay. So let's go back. What we're going to do is now we're going to import. Let me rename this to school class and say, let's do, I'm going to use the other syntax, which is from school class import school class. So I'm importing a specific thing from this. Just another way to do an import. But what it lets us do is it avoids the dot. So down here, we have two students. I'm going to say first class, let's say gym class equals, we're initializing a class. Now, we didn't use an init, that initializing special one. We could have, but if you don't, you don't strictly need it. You just don't have any of your attributes set. But what we do want to do is we want to do gym class dot add student first student, gym class dot add student second student. Okay. And now let's do a little loop. So we're going to go back to our for loop. So let's say all gym students equals gym class dot what was it, dot get class roster. Okay, so then a for loop for current student in all gym students. Remember that in Python, you can iterate over a list in the syntax. And we're declaring whatever index you're on currently, you're setting it as current student. So now we can do print a registered student is colon, and then we can do plus. Now, current student, if you think about what we've done, we've added a student, which is a student class. A class or an object is not something you can just add to a string. Like you can put a string and a string together, but a string and an object doesn't make sense. So we need to get from this student, we need to get something from them. Let's say dot get, let me go back to where we define student. So there's a get full name. So let's use that one. Student get full name. So because student is a student object, that object has the method, all the methods available in the original class, including the get full name. So this should work. Let me go ahead and run it. All right, there we are. A registered student is full name. A registered student is full name. So what we've done is we have described the concept of a class, the abstract concept of a class as a set of attributes that we're familiar with, as a start time and end time. We didn't do anything with it yet, and a list of students. We can keep going. We can add name and teacher and all these other things. But we also had kind of an even more primitive object, which was a student. And we were able to give that class object instances of the student object. And so now as we're building our code base, we are using concepts that are inherently familiar to us. And we're starting from a very generic concept like a student, and then we're generalizing out to broader concepts like classes, school classes, and we are kind of keeping up with our definition of how we view the world. And so that's really the beginning of what's really interesting with object-oriented design. You are describing your entire process or system as objects, and then you're just controlling how all the objects are interacting with each other. So almost all of Python, especially production Python, is going to be object-oriented. They're almost all classes behind the scenes. Let me show you. Let me use chat maybe. Give me a basic Python NP example. NumPy example. All right, great. Let's start with just these three. So we're going to do import NumPy as NP. Now, what is NP? Print the string of NP. What is it? NP is called here a module. Okay, so it's going to be one of these complex objects. You know, it's a whole chunk of code. Now the next thing that we're going to do is use it by saying a equals np.array, and then we're going to pass it an array 1, 2, 1, 3, 5, 6. And then yeah, a is an array. Now you'll notice that we called the NP module, and then which is a class ultimately, and we called this dot array on it. Well, what is NP dot array? NP dot array is a method. It's a function inside of this NP dot, and what it returns is this weird array type. So A is this weird array type. It's a list-like object. You know, it has a 0th index and a 1, 2, and you know, there's 4 indexes here, and it's list-like, but it has some other things that it doesn't have. So, for example, I'm I'm seeing that you can take a matrix and do a transpose. Transpose is like if you have something going left to right, you make it go up to down instead. So let's do A dot capital T. Is that right? Apparently. Hmm. I'm not as familiar with some of the math stuff, but we can do, for example, I think we can do B equals A times A. So um, a a list times a list. That's something that you can do in NumPy that you can't do very easily in um, normal Python. So you have these kind of superpowers that you're getting by using objects, whereas normally you would use basic primitive uh, variables. By using these objects, you have more functionality kind of coming along with it. And the details don't matter too much for like what the libraries do, that you kind of learn those as you need to, but it's more about the concept right now that you can have classes and that the classes allow you to track some of these attributes. And generally what you're normally doing is you're initializing them or setting them up. Um, and you're just kind of using variable names in all of your code. You're just saying whatever first name is, set it. And then whenever you need to use it, you just say self.firstname. You don't actually care what it is when you're writing the code. You only care when you're, doing the very first time setup of it. And then from every point forward, you can just call the function or the method names. So going back to the kind of status check, let me give Olivia another chance. How are you feeling on this? What's your level of comfort with classes versus functions?
Um, I think I probably need to do like work on my own to be able to fully understand. Like just playing around with this a little bit. Um, but I think it's like sort of makes sense so far.
Okay, that's probably how it is for everybody. It's kind of theoretical until you start to build these things out yourself, and you think, how would I want to, you know, build an object that represents a class? Like, what are the parameters of the class I want, and like, what else do I want to add? Um, and why would I do that? Why do I want to build a class manager? And the answer is that, well, you can build higher and higher levels of abstraction. Well, now that I have classes, I could have a semester object, and I could have sets of classes, and you can have kind of things relating to things using terminology that as a human should be very understandable. You know what a class is, you know what a student is, and you're just kind of creating the code behind it. Um, yeah, let's move on. I think some of these things will become more obvious as we continue through the course of the whole summer and then school year and such. But as you say, I do think there is a good opportunity to slow down and think about these as you're going through self-study, and that's important to know in part of this process. Um, Before we do that, though, I do want to give the other folks a chance. So I guess Anushka, what's your level of comfort, and do you have any questions as far as like what a class is, a function versus a method? And Anushka, I see you as unmuted, but I can't hear you. Okay, go ahead.
Hello.
Yes,
Can you
now
hear
we
me
can
now?
hear you. Yep.
Okay. I was saying I'm probably at the same state as Olivia. I think I'm a little bit overwhelmed to even know what question to ask, but I do kind of get the point of object-oriented programming and like the difference between a function and a class. I think is one of the points of it like it's just more applicable to the real world and like easier for like us as humans to I guess like understand it and apply to what we want to do because it's like modeled after the objects that we're using. I don't know.
That's right. So a class and object-oriented design are intimate. They really mean the same thing. You use classes to build the object-oriented design. And yes, absolutely. The reason you use a class is to model things that are intelligible in a way that you would want to model them, but also to only write the code once and then be able to reuse it no matter the situation. Whoever swaps in different parameters, different things, um, you can kind of swap it in, and that's very similar to kind of the mandate of a function. The function is just something you can call that lets you reuse code. So is a method, right? A method is just a thing to reuse code, but a method is always inside a class, and a function is just it's not inside a class. It just exists. Um, so you can declare a function anytime before you call it. So you'll see that we're putting the definition for the function up here, but we're not calling it until we're down here. But that said, I can call it as many times as I want. And the whole point is just to save you code and let you do complex stuff somewhere else.
Right. So the thing that you're showing us, like this whole code that you wrote is like, for example, like you're initializing a class for a school and you would be able to like reuse this for any future courses or anything like that.
Yeah. Yeah, so we've created an instance of gym class as just a class, but we could also create an instance of art class, which is just another type of class. And
Mm-hmm.
in that instance, I hate art, so we're only going to add Olivia.
Olivia. Okay.
So we're like we're able to do something different without having to rewrite any code. But
Right.
yeah, we wrote one time we wrote a generic description of what a class is, and from every point in the future after that, we can just reuse that definition.
Okay. Okay.
And then Angela, do you have any questions that come to mind or any details you'd like me to revisit at this point?
Right now, no. I'm still soaking it all in. Um, I think later I really want to play around with the app. Maybe like watch a YouTube video. But we're good right now.
Sounds good. So let's plan on what I'm hearing is that there's a strong need for circle back. So I'm going to make progress on today's talk, but let's plan next week on circling back to functions and methods and classes one more time, just to make sure that we're reiterating and hopefully making progress. So try your best. Do ask if you have pointed questions or even general questions. Just let me know. But I do hear and acknowledge that it's very overwhelming, and the only thing I can say is like give it some time. Do read the literature, and then try it out a few times, and it'll make more and more sense. The good news is that if you learn it for Python, it is very, very similar for almost every other programming language. If you learn one language, all the other languages are very easy to learn at that point. So learning your first one is the hardest, and then it gets a lot easier. All right, so there was something specific that I wanted to add, which was an application of reading Excel files. Now, when we talk about Excel files, you know, they are we know them to be let me just create a new one. We know them to be kind of tabular based, like based on tables, right? And we generally know them to have like column name, you know, and then like attribute, you know, like all these things. So maybe there's like, again, maybe this is students again. So this is F name, L name, age, and then you can do things like have a list. You could say family names. Let's say pet names. And then you have, obviously, the rows are where you have the data. So you'll notice that I'm comma separating inside of this one. All right, and now when you go to File, Save As, right? The default is this XLSX. I'm going to go ahead and save that. We're gonna create our I need a just create a new folder real quick. So we'll call this student roster.xlsx. So first of all, default Windows does not show you file extensions, and that is only good for general people. You're a programmer now, and so you need to enable file extensions. What you do is go to your top level. You go to, I think, options view, and then there's this where is it? Hide extensions for known types. You want to uncheck that. And then there's also like hidden files, which I like to see. The most important was the file extensions, though. If you have that, if you can't see what the file extension is, you're at a sincere disadvantage. You don't know what kind of file you're working with. Normally, you can single click on it, and somewhere in the information, or if you go to properties, it'll tell you what type it is. But just enable it so you can see it. And you can also see it from command line pretty easily. Change directory to so the file is this .xlsx. I'm going to save now another one, and I'm going to pick comma delimited value. So it's comma CSV. It stands for comma separated value, but they call it comma delimited there. And we'll get into that right now. So you'll see I have two files. They're both going to have the same data. I'm going to right click and open student roster in Notepad++, and you can see that in comma separated value notation, everything that's in a column, the count of the columns are separated by these commas, right? So column 1 is everything to the left of the first column, comma, and then column 2 is everything after that next comma, etc. You'll see that in the situation where you have these complex values, it does something special, which is it wraps that whole sequence in a special case character, and that's the quoting character, in this case double quotes. So there are ways to have commas in your text, like if one of these values was filled with a paragraph of text, you can still do that in CSV format, but you have to wrap the outer level of that in a known quoting symbol, and you want to use something that wouldn't appear in the values. So double quotes are like the default, but it could be anything technically. Now that's great. That's as simple as it gets. Text file. It's a CSV file. If we go and open XLSX in Notepad, you'll see that it's a bunch of garbledy-goop. And what it really is it is a it's a binary format. So this is binary. These are ones and zeros. It's just that some of the ones and some of the zeros relate to these characters, and so it's trying its best to render the ones and zeros. But basically, when you see stuff like this, you know that it means that it was binary behind the scenes. So that's what I'm saying here, that XLSX is a complex data type. It is not easy to work with XLSX in Python. It's not impossible. In fact, there's a library for it, because there's a library for everything in Python. But it is notably more challenging than CSV. And so as a data scientist, you have a preference for CSVs. And that's not a big deal. If you get an XLSX, generally that's fine. Just go ahead and save it as a CSV, and you're off to the races. But you can see why CSVs might be easier to work with in Python. They're a lot simpler. I'm going to do something that Notepad++ has. I recommend everybody on Windows get Notepad++. Unfortunately, for the other operating systems, I don't know what the equivalents are. Do some research. But there is a show all characters, which shows the invisible characters. So one thing to know about, like when you push enter, what is enter, right? And what is this whole I'm going down a line business? And the answer is that there actually are bytes that you're creating for that character. And in Windows, that's actually 2 bytes. One is a carriage return, CR, and another is a line feed. Carriage return, imagine the days of typewriter. The spool gets to the end and you have to zip it back to the left to keep writing. That's a carriage return. Line feed, similar concept. It had to do with the original printers back in like the 70s and 80s. But in Windows, it does both. For whatever reason, Linux only does the LF line feed. Generally not a big problem, just it can come up in some rare cases. In any case, there is an actual return. So if you imagine, if I push save on this and it's saving to file, right, to a file, what is it actually doing? Well, it's turning this data into a series of ones and zeros in memory. And that memory is actually sequential, right? So at position 448, that's where this file is stored. It's stored at position 448. It's going to start adding bytes of data left, from left to right, all the way here. And then when it gets to carriage return, these are just more data. And so essentially, it's like the whole thing was in a single line, and then these carriage returns were just special cases of characters, because that's basically how it's treating it in memory. When we are parsing this file, there's a few ways to do it. So let's actually quickly do the old school way. We're not going to use a library. We're just going to open this file, Python open file, and read lines for new lines and split each line by a comma. Okay. So let's just go ahead and go back in. We're going to create a new file here. We're going to call this one CSV manager.py. Best practice is actually to have this be a class. This would be like a service class. It does something. So CSV manager. And let's call let's create a function called open file, and we're going to pass it path. Let's circle back to that later. Let's just do a print testing. We'll do that if underscore name underscore equals underscore main. So if it's the main thing being called, run this, otherwise don't. And we're going to just call my manager equals a new instance of a CSV manager. And then we're just going to call my manager dot open file. Path is, let's just do temp for now. And the if statements always use double equals. I forgot to have that. So if this equals is true, then we run this. So what I'm going to do right here is call it in its kind of primordial state. And this is something I recommend, is like test quickly. Don't build 50, 60 lines of code and then test. Test very, very incrementally and troubleshoot as you go along. You'll notice I actually do have a bug, and the bug is that I didn't pass in the self here. I think you have to pass it in even if you don't use it. So I'm going to pass in the self. All right, so all we've done in this class is, if it's main, which it is, create an object called my manager, and then call the open file method, passing in temp, and all it does is print it. But let's now actually pass it a path. So that's where this code comes in. In the open file, first of all, I have to make sure that it's tab indented appropriately. So def starts here 2 tabs in. So 1, 2, and in the IDEs, you can just highlight and select everything. So it's opening a file here as a read-only file and setting it up with a name file. Now this doesn't exist, so let's actually set this up. So first of all, this student.csv needs to exist here. So let me move that there. Now we have student roster.csv in the same location. So let me go ahead and student roster.csv. We're going to open student roster as a read-only file. Read-only files, obviously, you can't write to them. So it's a safety thing. You don't want to overwrite a file that you're just extracting data from by accident. So you open it read-only. Now for line in file, we are now getting a line. And then we're introducing a few things. Strip is a Python function for strings. So if let's say that my string was my string equals space 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 hello exclamation point space space, like that. So if I print my string, you see it has all that. If I print my string dot strip, you see that it strips the leading and trailing white spaces. It's just a cleanup function. So for our line, whatever it is, remove the leading and trailing white space. The split is something that you can do on a string as well. So if we go back to this and we say my string dot split on something, so you're splitting relative to something. Let's split relative to the letter E from the hello. And what we see is that we have everything up until the letter A, up to the letter H, but not including the E. Then it splits it at the E and then gives you everything after. And because there's two things there, it's always going to return as a list. So you can turn your string into parts. Let's do, so my string hasn't changed. It's still hello. So let's do now a myString.split on the letter L. And it's more complicated now because there's two L's. So it also adds a split between this first L and the second L, but there's nothing there. So it gives us this empty thing, but it still splits there. All right, so what we're splitting on is this comma, right? So I'm going to add some learning stuff here. So let's do print string before, or I'm going to call it line before colon space plus clean line. Then we have parts, print parts after colon space plus, now that's a list type, so I'm going to cast it into a string with this str function. And then, well, it's the same thing as that, print results. All right, so let's go ahead and run this. Yes. All right. So line before, so we had a headings line, and then after we split by the comma, it does this. The next line is this. Now this is where the trick comes in. You'll recall that we had this complex thing here that's supposed to be treated as one column. Python's not so smart. You have to be more declarative. So it's actually trying to split with quote Zola up until the end of that. And then it puts this other quote over here. So that's actually expected behavior from the perspective of Python, but it's not very elegant. If we wanted to not do that, we would have to write some special code to handle this special instance where if it starts with a quote or something. I'm not going to write that code because that code already exists. Instead, let's do open Python, open CSV file and print each row in Python. Again, I encourage all the modern generation to use ChatGPT. So, all right. There is a built-in Python class called CSV. If you start to go into these imports and you just Google the names, it will either occur in the Python documentation, in which case you know it's a built-in function, or if it's like a GitHub or something, then you know it's not standard Python, it's an add-on. All the standard Python stuff, you don't have to install anything. It's already there. CSV is one of these very common ones. It's already there. It gives you a guide on how to use it. And so learning to learn from the Python documentation is very helpful. Likewise, ChatGPT is a good way to learn too. All right, so what it's saying is open the CSV as a CSV file, and then once you've opened your file, the magic line is actually this one: create a reader which is this CSV class, and it has this .reader function. And the .reader function is going to return a reader object. And the reader object lets you iterate through the rows as follows. So let's go ahead and capture the magic parts of this in our example. So we already have the file being opened. I'm going to comment all that out. Won't delete it just for historical reference, but let's go ahead and get this stuff set up, fix the tabbing. All right, so the name of our file is called file. We've created a variable called file. I might just change that to my file. I prefer that syntax. All right, my file. So reader equals CSV reader.myfile. Then we're just going to iterate over it and print the rows. Let's see. See what happens when we run that. Oops, without that. All right. So it does a few things. So now for every row in reader, we have a list object. And you'll notice that it took care of that special case for us. It put these two together. And so every list is 4. Now you'll notice that we have 1, 2, 3, 4 empty rows. If we go back and double check, we have 1, 2, 3, 4 carriage returns. So in CSV, it does treat blank lines as significant rows. I'm just going to go ahead, delete those, resave the file. And if we run it again, oh, I need to edit them over here. Sorry, because I made a copy of it. So delete those, save that, run it again, and yeah, now it's gone. Okay, so that is opening a CSV. Now that, so an instance of how you might use this, right? So first of all, we've done a few things that are not great. One of the things that we did is we hard-coded what file to open. I'm going to get rid of that and make it dynamic now. So we had intended to pass in this path. So let's go ahead and use that. Path is now a variable that we're passing into open file. So let's set that up ahead of time. So my path equals, and then we're just going to pass it my path. So what it's doing is it's calling open file. Open file expects to receive a path object, which it is receiving, and that path object is going to be used to open this file. So first of all, this file needs to exist. If it doesn't exist, let me make one that doesn't exist. So here's a file name that does not exist. We're going to get an exception, and we're going to get a useful exception that says file not found error, no such directory. Right now, we're not going to get into exceptions too much, but in any case, it does pass in whatever path you put here. All right, so now that we have that, so we have opened a file. We're printing the rows. However, instead of printing them, let's just return the reader. And let's capture it now. So we're saying my data equals that. And now I can do stuff with my data. So again, for line in, I would say probably for row in my data, get me print, or let me do f name equals row 0th index, and L name equals row 1st index. I'm doing this with prior knowledge of what the CSV looks like. I know with prior knowledge it's this. I think there's something about headings too. Let me find heading, right header, header. has header is something. Well, it's okay. Well, let me just go ahead and print this, right? So let's do print. So let me do a count, right? So count equals 0. Every time we iterate, we'll do count equals count plus 1. And so we're going to say on row plus string of count, whatever row we're on. Name is plus fname plus space plus lname. All right, let's go ahead and just run that. Python CSV manager. All right, it's giving me an error. IO operation on closed file. What's the issue? Okay, so return reader. All right, so I reader. If we go back, reader is a special type of object for reading data. We actually have to get the data out of it. I forgot to do that one step of actually using the reader. So what I'm going to do is say lines equals an empty list, and then we're going to iterate over for row in reader. That's the syntax we had before, and we're just going to do lines dot append just row. And then instead of returning the reader, which is just this object for getting data in, we're actually going to return this list, which is a list of row values. And that should now work. So let's try that. Yeah. Okay. So now you'll notice that it's not accounting for this first column, right? So let's go ahead and do a one-time exception. So if count equals 0, then continue. Continue is a special word. What it does is you use them in loops, and it basically passes this iteration. It's kind of like it's kind of like a mini return. It just breaks the execution of this loop and moves on to the next iteration. So continue continues past count. So if we run this again, hold on. So okay, so now it didn't run any of the lines. Or here's what it did. Here's what it did. It got to this continue and then quit and moved on, and then it got to this continue and quit and moved on. And it did that every single time because look where the count plus 1 is. It's below the continue. So what I need to do is add another one. I need to change it, and then that way the second time it hits, it won't die right there. It won't die at that place. Now when I run it, it isn't skipping, or it isn't hitting this continue any a second time, because the second time around count has been incremented. Count is now 1 on that second go around. So this is false, and then it continues to do the rest of the stuff. So we've now accounted for the header. So that is using CSV files, and that is kind of as a data scientist, something you're going to need to be very familiar with. There's a lot of ways to do this. The way I've shown you is kind of like the generic Python-y way to do it. What I'll say is that some of the more advanced data science libraries, specifically pandas, has its own way to do opening CSVs. The syntax will be very similar. But you know, this ultimately it doesn't really matter how you load in the data, as long as you're, you know, comfortable using it. There are a few things to be aware of. You'll notice here that this part of the code is after you've opened the file, you are loading everything into a variable called lines. Keep in mind that if this file was like 10 gigabytes, then you're loading into memory a list that's 10 gigabytes long. And you might run into a data file that's too large to hold in memory. Most beginner programmers never run into that. But because we know that we're going into large data sets, you know, at some point you might run into a file that's larger than your system can process. And that's okay. There's other techniques. Notably, you don't open the whole thing all at once. You open a few lines at a time and process those, and then like fetch some other lines. And you kind of chunk a little window that you're reading in the file at any given time. So you can work with larger data than you can open in your RAM, but just be aware that literally there is a variable called lines that has the full contents of your entire file in it, and it's in that Python data structure. All right, so at this point, that is a sufficient level of kind of introductory Python to start working on scripts and start to, you know, really look at some applied examples. It's not to say that your learning is over. It is to say, though, that you know enough of the fundamentals to start to self-educate in applied examples. And so we'll try and push more and more applied examples going forward.